In this video, I'm going to demonstrate the volume threshold step parameter. The idea here is that rather than specifying a duration for an actuation to occur, we are going to set a threshold where we will only proceed to the next step in the protocol if a certain percentage of the expected volume is measured on the electrodes that we're actuating. So for example, if I turn on real-time mode, we're applying 100 volts, we've got some liquid on here, and if I turn on the electrodes, you can see that the liquid moves to cover. And this time I want you to just watch the capacitance value as I turn off an electrode, so it goes down to femtofarads. And then when I turn on an electrode, it will start at a low value, so 7. It goes pretty fast. Maybe I'll turn down the voltage so that it's easier to see. So maybe turn the voltage to 85 just to slow things down a little bit. And we can see that value going up as the liquid covers the electrode. So there it maxes out at around 24.5 picofarads, somewhere in that range. Now, we can use this capacitance measurement to measure the liquid capacitance, or to measure the capacitance associated with liquid covering an electrode. So here we're relying on the operator to tell us that this electrode is totally covered with liquid. And the capacitance that we're measuring doesn't vary with the liquid that's used, except in very rare circumstances. So, but in the vast majority of cases, the liquid has no effect on the measured capacitance. And so, but what the capacitance does depend on is the thickness of the dielectric on the chip. And this can vary slightly from chip to chip. And so that's why we provide a calibration method for determining what the sheet capacitance is of a given device that you have inserted, or a given chip that you have inserted. And that's what this value is. So I'm going to calibrate it for this chip by right-clicking on an electrode that I have purposefully covered with liquid completely, and then by clicking the Measure Liquid Capacitance. Oops, sorry. You have to actuate the electrode first, right-click, Measure Liquid Capacitance. And you can see that that has updated this value to 4.3 picofarads per millimeter squared. What that allows us to do is that when the drop bot is measuring the capacitance, we know the shape of the electrode, so we can compute the expected capacitance that we should measure if that entire electrode was covered with liquid. And then by doing that, then we can specify a percentage threshold that we must reach before we consider that actuation to be complete. So for example, I'm going to turn real-time mode off, and I'm going to turn on this electrode on the step, and I only want this step to be considered complete if we've reached over 95% of the expected capacitance. If the volume threshold parameter is used, the duration now specifies the maximum time that we will wait until this threshold is met. And if that threshold is not met after the specified duration, then the protocol will stop and an error prompt will be displayed. So I'm going to set this to a relatively high number, so 15 seconds. But note that we don't expect to actually wait 15 seconds. We expect that the electrode will become covered well before then. So now I'll press play, and you'll see that it will move until it's covered, and now the 95% threshold was reached, and the end of experiment is now detected, or executed. Now, this becomes really useful if you combine it with multiple steps in your protocol. So for example, on this step, I will turn on that electrode, wait till it's 95% covered. Then on the next step, I'm going to turn on an adjacent electrode, and then the next step, another electrode. And here I'm just using the S and D shortcut keys for the previous and next buttons respectively to jump between steps. So I'm going to also change the voltage. So here I've selected all the steps. I right click on the voltage column, and I'm going to change the voltage to 110 just to make it move a little bit faster here. I'll start by clicking the first step again and press play, and we'll see that the protocol proceeds as fast as possible while waiting for that threshold to occur. Now, here I was showing an example where I was explicitly specifying the actuations, but this can also be applied using routes. So, for example, I can click and drag to create a route for this drop to follow, and this volume threshold now will be applied to each actuation along the route. Now, this duration is now the maximum duration that we will wait for each actuation along that route. So I will now press play, and it will actuate in sequence and wait until the threshold is met before moving on to the next electrode. And using this technique, you can easily move drops across the chip, moving as fast as possible while making sure that that the drop is actually moved before proceeding on to the next step. And note that the blue color here corresponds to what we call dynamic actuations, and these are actuations that are not set explicitly, but that are done automatically by the software through a step. So these are turned on and off based on the path along a route, rather than, for example, if I click on an electrode, that's an explicit actuation of that electrode that the user is specifying, whereas the blue highlighting of the electrodes is the software controlled actuations along a route. So let's do this again, starting at the beginning, step 1. It will play, it will move along the route, waiting for that threshold. Then it will move on to the next step in the protocol, and we'll wait for the threshold as well. That's the end of this video, where we've demonstrated how to use the volume threshold parameter after performing calibration of an electrode that is covered completely with liquid to determine the device capacitance.